Reality does not end in an explosion. It fades, slowly, silently. There is a future where time loses meaning, a future where there is no light, no structure, no events, and the most disturbing part is this: nothing happens anymore. This is not science fiction. This is the most serious prediction modern physics makes about the fate of everything. Not just stars, not just galaxies, everything, space, time, reality itself. Right now, the universe looks alive, galaxies spin, stars burn, planets move, energy flows, light travels across billions of years, but beneath all of this activity, something deeper is happening, something quiet, something unstoppable. The universe is running down. Every second, energy spreads out. Every second, structure weakens. Every second, the universe moves closer to a state where nothing can ever happen again. This idea has a name. It is called the death of the universe. But what does that actually mean? Does everything explode? Does space collapse? Does time suddenly stop? The real answer is far more unsettling. According to modern physics, the end of the universe is not a dramatic event. It is not a sudden collapse. It is not a final explosion. It is a slow disappearance of all activity. A future where stars no longer shine. A future where galaxies drift so far apart that they can never meet again. A future where even black holes, the most powerful objects in existence, slowly vanish. And beyond that, something even stranger. A universe where change itself disappears. Because here is a fact most people never hear. Time only makes sense when something changes. If nothing moves, nothing evolves, nothing interacts, then time becomes meaningless. In the final state of the universe, there may still be space. There may still be particles. The laws of physics may still exist, but nothing happens. No events, no processes, no story. Just an endless silent stillness. This idea is not just speculation. It comes from decades of research in thermodynamics, quantum physics, and cosmology. Scientists have studied how energy behaves over time. They have studied how the universe expands. They have measured how galaxies move away from each other faster and faster. All of these discoveries point to the same conclusion. The universe has an ending, and it is far stranger than anything imagined before. One of the leading voices explaining this idea is Brian Greene. He is a physicist who studies the deepest laws of reality, space, time, the nature of existence itself. His work explores questions that go beyond everyday science, questions about the beginning of the universe, and more importantly, its final fate. According to Brian Greene, the end of the universe is not just about objects disappearing. It is about reality losing its ability to do anything at all. This is the part most people miss. When people think about the end, they think about destruction. They think about fire, collapse, chaos. But the real ending is the opposite. Chaos, it is perfect stillness, a state where everything is evenly spread out, where no region is different from any other, where no energy flows from one place to another. And without differences, nothing can happen. No motion, no heat, no light. Even the smallest event requires a difference, a change, a flow of energy. Remove all of that and reality becomes frozen. This idea comes from a principle called entropy. Entropy measures how spread out energy is. And one of the most important laws in physics says that entropy always increases, always. It never reverses. It never stops. Over time, this means the universe becomes more uniform, more diluted, more quiet, until it reaches a final state where nothing more can change. That is the true meaning of the universe dying, not destruction, not disappearance, but the end of all processes. In this video, you are going to see how this happens step by step. You will see how the universe is already moving toward this fate right now. You will learn what happens when the last stars go dark. You will discover why black holes, the most powerful objects in existence, are not eternal. And most importantly, you will understand what happens to reality itself when there is nothing left to change. Because the final state of the universe is not just empty. It is something far more difficult to grasp. A reality that still exists, but has no events inside it. A universe where time has no meaning. And once you understand this, the way you see existence will never be the same again. Welcome to the channel. If you want to explore the deepest ideas in science and the true nature of reality, make sure to subscribe and stay with us until the end. The end of the universe is not something waiting in the distant future. It has already begun, right now, quietly, constantly. The space around us is expanding. Not just expanding, but accelerating. This was one of the most shocking discoveries in modern science. For a long time, scientists believed gravity would slow everything down. They expected the universe to gradually calm itself. The opposite is happening. Galaxies are moving away from each other faster and faster. The farther they are, the faster they escape. It is as if space itself is stretching, pulling everything apart with increasing force. There is a hidden driver behind this, a mysterious component called dark energy. It makes up most of the universe, yet no one fully understands what it is. Its effect is clear. It pushes space outward. It dominates over gravity on the largest scales. Because of this, distant galaxies are already beyond reach. Their light will never reach us again. Right now, there are regions of the universe that have already disappeared from our observable reality. Not because they vanished, but because space expanded too quickly. This means something important. The universe is becoming more isolated. Over time, every galaxy will find itself alone, surrounded by darkness, cut off from all. Others, but expansion is only part of the story. There is a deeper process unfolding beneath it. A process that governs everything in physics. It is called entropy. Entropy measures disorder. It measures how spread out energy becomes over time, and one of the most powerful laws in science says that entropy always increases. Always. In the early universe, energy was concentrated. Matter was close together. Structures could easily form. Stars ignited. Galaxies took shape. Everything was active. Everything was happening. Now, energy is spreading out. Stars burn fuel and release energy into space. That energy does not stay organized. It drifts. It disperses. It becomes less useful over time. Even the light from stars, after traveling for billions of years, stretches into longer wavelengths. It loses energy as space expands. It fades into a cold background. This is a detail most people never think about. Light itself is slowly weakening as the universe grows. Over unimaginable timescales, this process continues. Energy becomes more diluted, less concentrated, less capable of driving change. And without concentrated energy, nothing interesting can happen. No new stars, no complex structures, no dynamic systems. Everything moves toward uniformity. This is what makes the end of the universe so strange. It is not caused by a single event. It is the result of countless small changes adding up over time. Every star that burns, every photon that travels, every expansion of space, all of it pushes the universe closer to a final state of maximum disorder. Right now, the universe is still full of activity. Stars shine. Galaxies collide. Energy flows. But compared to what came before, it is already quieter. And compared to what is coming, it is still incredibly alive. The process is slow beyond human understanding. It takes billions and trillions of years. But the direction is clear. The universe is not building towards something. It is winding down. And this slow fading sets the stage for the next phase, where the brightest objects in existence begin to disappear one by one. There will come a time when the universe can no longer create new stars. Right now, stars are born inside vast clouds of gas and dust. Gravity pulls this material together. Pressure builds. Temperature rises. A star ignites. But this process depends on one thing: fuel. And that fuel is running out. Each new generation of stars uses up more of the available hydrogen. Over billions of years, the easy supply disappears. What remains becomes harder to gather, harder to compress, harder to ignite. Star formation slows down. Then it stops. No new light will be born after that point. The last stellar nurseries will fade into silence. The universe will lose its ability to create fresh sources of energy. What remains are the stars that already exist. They continue to shine for a time. Some burn slowly like red dwarfs. These small stars can last for trillions of years, far longer than stars like the sun. They stretch the final chapter of cosmic light. But even they have limits. Eventually, every star runs out of fuel. When that happens, the star dies. Some stars swell into red giants and shed their outer layers. What remains is a dense core called a white dwarf. It no longer produces energy. It only glows with leftover heat. Other stars end in more violent ways. Massive stars collapse under their own gravity. Their cores compress into neutron stars, objects so dense that a single teaspoon would weigh billions of tons. And the most massive stars collapse even further. They form black holes, regions where gravity becomes so intense that nothing can escape. These remnants do not shine like normal stars. They do not generate new light. They are the leftovers of a once active universe. Over time, the balance shifts. Bright, living stars become rare. Dead objects take over. White dwarfs cool down slowly. Over trillions of years, they fade into black dwarfs, cold, dark, invisible. Neutron stars lose energy as well. They spin down. Their radiation weakens. They become quiet. Black holes remain the most extreme objects, but even they do not shine unless something falls into them. In an empty universe, even they become silent. Darkness spreads. This is not sudden. It is gradual. Light disappears piece by piece, star by star. There is a lesser known detail that makes this phase even more unsettling. In the far future, the night sky will not look like it does today. It will not be filled with stars. For any observer that exists in that distant time, the sky may appear almost completely empty. Galaxies will have moved far apart due to expansion. Most stars will be gone. The remaining ones will be faint and isolated. The universe will feel small, even though it is still vast. Time still moves forward, physics still operates, but meaningful events become rare. No new stars form. Few objects interact. Energy becomes harder to use. The universe enters a long, quiet era. A place where change slows down, a place where activity becomes scarce, and as the last stars finally go dark, the universe prepares for a phase where even the most powerful objects left behind will begin to disappear. After the last stars fade, the universe enters a new phase. It is ruled by darkness and gravity. Black holes become the dominant structures. These objects are not rare anymore. They are everywhere. Formed from the deaths of massive stars and the collapse of ancient galaxies, they remain as the most powerful survivors of a dying universe. They do not shine on their own. They do not create light, but their gravity shapes everything around them. In this era, most of the remaining matter has already fallen into them. Over vast stretches of time, black holes consume what little structure is left. Stray planets, cold stars, and drifting gas all spiral inward and disappear. Each encounter releases a brief flash of energy. Then silence returns. Eventually, even these fleeting events become rare. The universe grows emptier. Distances grow larger. Encounters become unlikely. Black holes are left alone. For a long time, scientists believed these objects would last forever. Their gravity is so strong that nothing escapes once it crosses the boundary known as the event horizon. But this is not the full story. In the 1970s, Stephen Hawking made a discovery that changed everything. Black holes are not completely black. They emit a faint form of radiation. This process is now known as Hawking radiation. It comes from quantum effects near the edge of a black hole. Space is not truly empty. Tiny fluctuations constantly create pairs of particles. Normally, these particles vanish almost instantly. But near a black hole, something unusual can happen. One particle falls in. The other escapes. To an outside observer, it looks as if the black hole is slowly losing energy. This means black holes are not eternal. They evaporate. At first, the effect is extremely weak. Massive black hole can take longer than the current age of the universe just to lose a tiny fraction of its mass. But over unimaginable timescales, the process continues. Trillions upon trillions of years pass. Then far beyond that, as a black hole loses mass, the radiation becomes stronger. The process speeds up. The final stage is sudden and intense. After an incredibly long lifetime, the black hole disappears in a final burst of energy. This is one of the most surprising facts in all of physics. The most powerful objects in the universe do not last forever. They slowly fade away. During this era, black holes define structure. They are the last anchors of gravity, the last places where matter gathers. But even they cannot resist the slow drain of entropy. One by one, they vanish. Supermassive black holes, the giants that once lived at the centers of galaxies, take the longest. Some may last for numbers of years so large, they are difficult to even express. Yet even they have an end. As the final black holes evaporate, the universe loses its last complex structures. No stars, no galaxies, no massive objects holding anything together. Only scattered particles remain. Energy becomes even more diluted. Space becomes even more empty. The universe reaches a state where almost nothing interacts anymore. An ocean of darkness stretches without interruption. And with the disappearance of the last black holes, the universe moves closer to its most silent and final condition, where even the concept of activity begins to break down. After the last black hole fades, the universe enters its final state. This state has a name. It is called heat death. The name sounds dramatic, but the reality is quiet, almost impossible to notice. It is not about heat in the usual sense. It is about balance, perfect balance. In this stage, energy still exists. Particles still exist. Space still stretches endlessly. Nothing has vanished completely, but everything is spread out. Every bit of energy is evenly distributed across the universe. There are no hot regions, no cold regions, no dense areas, no empty pockets with differences that matter. This detail is crucial. All processes in the universe depend on differences. Heat flows from hot to cold. Particles move because of imbalances. Stars shine because energy is concentrated and released. Remove those differences and everything stops. In the state of heat death, there is no temperature difference anywhere. Every part of the universe has the same energy level, the same conditions, the same stillness. This means no work can be done. Work in physics is not effort. It is the transfer of energy from one place to another. It is the engine behind every event, every motion, every change. Without a difference in energy, there is nothing to transfer. No transfer means no motion. No motion means no events. This is the deepest meaning of maximum entropy. Entropy has reached its highest possible value. Energy is completely spread out. There is no way to rearrange it into something useful again. This is a point of no return. There is a lesser known aspect that makes this even more unsettling. Even at this stage, tiny quantum fluctuations may still occur. Particles may briefly appear and disappear due to the nature of quantum fields. But these events are random, isolated. They do not build into anything larger. They do not create structure. They do not lead to lasting change. They flicker and vanish without consequence. Over time, even these rare fluctuations become meaningless in the vast emptiness. The universe becomes a uniform field, no patterns, no complexity, no direction. Time still exists as a dimension. Equations can still describe it, but without change, time loses its practical meaning. There is no before and after in a meaningful sense, no sequence of events, no evolution, only an endless state that remains exactly the same. This is not darkness in the usual sense. Darkness implies the absence of light, but here even the concept of light loses meaning. There are no sources, no observers, no interactions to define it. It is a silent equilibrium, a universe that still exists but does nothing. This is the final prediction of thermodynamics, the ultimate outcome of a system left to evolve for an infinite amount of time. Every process winds down, every structure dissolves, every source of energy becomes useless. And in that complete stillness, reality itself begins to lose the very qualities that once made it dynamic and alive, leading to a deeper question about what existence even means when nothing can ever change again. At this stage, something deeper begins to break down. Not matter, not energy, but the meaning of reality itself. Everything that defines reality depends on change. Time, as it is understood, is not just a number on a clock. It is a measure of change. One event follows another. One state becomes a different state. That sequence gives time its direction. In a universe where nothing changes, that sequence disappears. There is no meaningful difference between one moment and the next. No event marks the passage. No process separates past from future. Time still exists in equations. It still appears in the structure of physics, but it no longer does anything. It becomes an empty parameter, a label without content. This is one of the least understood consequences of the universe reaching its final state. Time does not stop. It becomes irrelevant. The same idea applies to structure. Every structure in the universe depends on interactions. Atoms form because particles interact through forces. Stars exist because gravity pulls matter together. Light travels because electromagnetic fields connect space. Remove interactions and structure collapses. In the final state, particles are too far apart. Energy is too evenly spread. Forces have nothing to act on in any meaningful way. There are no atoms forming, no systems organizing, no patterns emerging. The universe becomes a smooth, uniform field. There is a lesser known detail that makes this even more strange. Even if particles still exist, their isolation makes them effectively invisible to one another. Without interaction, their presence has no consequence. A particle that never interacts might as well not exist in any observable sense. This leads to a deeper question. Can existence be defined in a universe where nothing can ever be observed, measured, or changed? Physics usually describes relationships, forces between objects, energy transfers, motion through space. But in this state, relationships vanish. Objects no longer influence each other. There is no exchange, no connection. Reality becomes a collection of disconnected points with no story linking them together. Brian Greene has explored this idea in depth. According to his perspective, the laws of physics may still exist in this final state. The equations remain valid. The framework of reality is still there, but nothing happens within that framework. It is like a stage with no actors. The rules of the play still exist. The structure of the theater remains, but no performance ever takes place. This creates a strange kind of existence, one where everything is technically present, yet nothing is active, no cause, no effect, no sequence, only a frozen backdrop that stretches forever. There is another subtle consequence. Information loses meaning. Information requires change, a difference between states, a signal that can be transmitted or observed. In a perfectly uniform universe, there are no differences to encode information, no signals to carry it, no observers to interpret it. Reality becomes silent in every possible way, not just visually, not just physically, but informationally. This is the point where the concept of existence itself begins to blur. A universe that exists but cannot express that existence through any event or interaction. And this leads to one final uncertainty, because even in this absolute stillness, physics leaves open a small and unsettling possibility that something unexpected could still emerge. Even in this final state, science does not completely close the door. Heat death is the most widely accepted outcome in modern cosmology, but it is not the end of inquiry. It is the end of everything we currently understand about large-scale change. Beyond that point, physics becomes uncertain. One of the strange features of quantum theory is that emptiness is never truly empty. Even in perfect vacuum, tiny fluctuations can appear. Energy can briefly form and disappear. Particles can pop into existence for extremely short moments. In today's universe, these events are harmless. They are quickly canceled out. They leave no lasting impact. But over unimaginable timescales, something unusual becomes possible. If the universe lasts long enough, rare fluctuations might become significant. Not because they are likely, but because time is so vast that even extremely unlikely events may eventually occur. There is a theoretical idea that in a fully empty maximum entropy universe, random fluctuations could momentarily create low entropy regions again. Tiny pockets where structure briefly returns. Most of these would collapse instantly. No stability, no growth, no future. But physics does not completely rule out the possibility that something larger could emerge under extreme conditions. Even entire new universes are sometimes discussed in speculative models of quantum cosmology, not as a confirmed outcome, but as a mathematical possibility under certain interpretations of physics. These ideas remain highly uncertain. There is no experimental evidence, no observation that confirms them. Still, they highlight an important fact. The final state of the universe is not fully understood. Another possibility is that the heat death state simply persists forever. No fluctuations large enough to matter, no transitions, no escape, a static universe extending without end, not changing, not evolving, just existing in perfect equilibrium. In that case, there is no final event, no final moment, only an endless continuation of stillness. The deeper issue is that science reaches a boundary here. Physics is built to describe change, motion, energy, interaction. It is powerful in explaining everything from atoms to galaxies, but when nothing changes at all, the tools of physics become quiet. Equations still exist, laws still apply, but there is nothing left for them to describe in a dynamic sense. Brian Greene has often emphasized that the mathematical structure of reality may remain intact even in extreme cosmic futures. The equations do not disappear. The framework does not collapse. But whether that framework produces anything meaningful without change is unknown. There is also the question of time itself in this context. If nothing fluctuates, nothing evolves, and nothing interacts, then even infinite time may not produce any noticeable difference. An infinite stretch of identical states becomes indistinguishable from a single moment that never changes. This leads to a fundamental uncertainty. Science can describe how the universe evolves up to this point. It can model the expansion, the fading of stars, the decay of black holes, and the rise of entropy. But beyond the final equilibrium, predictions become unclear. There is no confirmed theory for what, if anything, lies past maximum entropy. It may be a permanent silence, a universe frozen in place forever. Or it may hold rare and unexpected transitions that occur only across scales of time so large that they are almost impossible to comprehend. At this boundary, physics stops giving clear answers, and the fate of reality becomes a question that remains open, waiting for deeper understanding that may or may not ever arrive. The universe does not end with a bang. It does not collapse in fire or explode in light. It fades, slowly, quietly, without drama. First, the stars disappear. Then the galaxies drift apart. Then even black holes vanish after unimaginable time. Each stage removes a little more activity from reality. In the end, nothing is left that can change anything else. No energy flow, no motion, no interaction. Just a universe that still exists but no longer does anything. This is the most unsettling part of all. The idea that reality does not stop existing. It simply stops happening. Space may still stretch forever. Particles may still be there in some form. The laws of physics may still be written into the structure of everything. But there are no events left for those laws to shape. No stories, no processes, no transitions. Even time loses its meaning because nothing marks its passage anymore. This is the final state described by modern cosmology, a universe that reaches perfect balance, maximum entropy, absolute stillness on the largest scale possible. And once that state is reached, nothing inside it can ever bring change back. Again, it raises a quiet but powerful thought. Everything that exists today, every star in the sky, every galaxy, every moment of movement and light, all of it is temporary. The universe is not built for permanence. It is built for change. And change always moves in one direction, towards silence. Yet right now, the universe is still alive with activity. There are structures forming, light traveling, energy shifting, and time moving forward in ways that can still be felt. This moment sits in the middle of that long cosmic story. A brief phase where the universe is active, dynamic, and full of possibilities. And that makes it even more significant because compared to the future that physics predicts, this moment is rare. A short window where change is still possible. So while everything moves towards stillness, there is still a universe that can be explored, understood, and questioned. If you want to continue exploring these kinds of deep ideas about space, time, and reality, then stay with this journey. Like the video if you enjoyed it. Subscribe for more deep science stories like this.